let's look at algebra of vectors. Okay, equality of two vectors. So two n vectors x and y, where x is equal to x1, x2, and so on to xn, and y is equal to y1, y2, and so on up to yn, are equal only if their corresponding components are equal. Okay, which means x1 is equal to y1, x2 is equal to y2, or in general xi is equal to yi for all I belonging to 1 comma 2 comma so on up to n. Now here remember, order is important. So therefore 1 comma 3 comma 6 is equal to 1 comma 3 comma 6, but 1 comma 3 comma 6 is not equal to 6 comma 3 comma 1. Now coming to addition, so continuing with the same n vectors, x plus y is equal to x1 plus y1, x2 plus y2, and so on up to xn plus yn. So sum of n vectors is a n vector whose components are the sum of corresponding components of x and y. So say x is equal to 4 comma 2 comma 3 and y is equal to 1 comma 3 comma 2, then x plus y is equal to 4 plus 1 5, 2 plus 3 5, 3 plus 2 5. Now, in your mind keep comparing it with algebra of matrices. Exactly the same thing happens. Okay, now coming to multiplication of a vector with a scalar. So currently we are basically interested in multiplication of vector with a scalar only. So if k is a number and x is a n vector, then kx, or rather kx, is equal to kx1, kx2, and so on to kxn. So basically we multiply the scalar with each of the components of the n vector. Okay, so let us say x is equal to 1 comma minus 2 comma 5, and let's say k is equal to 3. Then kx is equal to 3 times 1 comma minus 2 comma 5, which is equal to 3 comma minus 6 comma 15. Now let's look at some properties. So if we have, let's say, 3 n vectors or n vectors, and p and q are two numbers, then x plus y is equal to y plus x. Similarly, x plus y plus z is equal to x plus y plus z. Now p times x plus y is equal to px plus py. Nothing great. All this we have already seen. Similarly, p plus q x is equal to px plus qx. And finally, p times q times x is equal to p times q times x. Commutative property, associative property, distributive property, This is also distributive property. Okay, so that is algebra of vectors. It's not a comprehensive one. It is what we need to know for us to continue with our abstract algebra course. That's it for now. Bye.